Okay, our topic for today is isotopic dating. And before we start talking about isotopic dating, we have to talk about a concept called half-life. Half-life is defined as the time it takes for half of a radioactive sample to decay. So if I have a radioactive sample, the half-life would be the time it takes for half of this radioactive sample to decay. So 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011, 1012, 1013, 1014, 1015, 1016, 1017, 1018, 1019, 1020. So as you can see, it takes 20 seconds for half of the sample to decay. And it's going to take another 20 seconds then for the other half of that sample to decay. And it's going to take another 20 seconds and another 20 seconds, and so on and so on. So that after 60 seconds, and I've undergone 3 half-lives, most of the radioactive sample has decayed. And eventually you will get to a point where the entire sample will then decay. Okay? So isotopic dating is a technology that scientists use by using this concept of half-life and figuring out how substances, the date of a substance, by looking at the amount of radioactive material that was left behind and using the half-life of that substance to determine how old something is. So one of the things that we use to isotopically date is carbon-14. Because the Earth is constantly being bombarded with cosmic rays from the sun and other stars and causing atoms to be transmutated. And one of the results of this is that nitrogen, because nitrogen is the most prevalent element in our atmosphere, the nitrogen in our atmosphere being bombarded with cosmic rays is being transmutated from nitrogen into carbon-14. Now, all living things on Earth contain carbon-14, and as long as you're alive, there's a constant amount of carbon-14 in you. So all living things on our planet are what we call carbon-based life forms. We take in carbon, and we take it in continuously. Plants take that carbon from the atmosphere in the form of carbon dioxide into their leaves, and then we take in the carbon from eating the plants and so forth. So when a living thing is alive, all of its carbon is carbon-14 that it's incorporated. So when a living thing dies, the amount of carbon-14 begins to steadily decrease because you now have a set amount of carbon-14 that's radioactively decaying. And that's determined by the half-life of carbon-14. So the half-life of carbon-14 is about 5,730 years. And so if you look at a once living thing, and you test a sample of its tissues, and you see that it has half carbon-14 and half something else, then you know that it's undergone one half-life, and that particular living thing died about 5,730 years ago. Okay, so the dating of once living material is accomplished by determining how much carbon-14 is left in the object. Now, because, you're eventually going to get to a point, as we saw in the little demonstration, that all of the atoms are going to radioactively decay, we really can only tell how old something is that's like from anything that's a little bit 50,000, nothing older than 50,000 years old. So if I find a living thing and all of its carbon-14 has radioactively decayed into a new substance, then I know that it has to be older than 50,000 years. Now, a problem is that the level of that this idea of carbon dating assumes that the levels of carbon dioxide in our atmosphere have remained relatively constant over time. And we know that that's not true. We know that since the industrial age, humans have been burning carbon-based fossil fuels and pushing carbon dioxide into our atmosphere, and we've been increasing the levels of carbon dioxide. So when you look at the carbon 14 dating method, we say that there's a problem because there's like a 15% chance of uncertainty. And if you remember when we were talking about finding the error analysis or finding the percent error of something, we want no more than 5% error for humans. Now, archaeologists are really social studies, history kinds of people. They're not true, what we would consider true scientists. So they're like, 15% error, that's okay with us. But a true scientist is like, I don't know, 15% error, that seems like a lot to me. So that's one of the problems with the carbon-14 method of isotopic dating. The dating of much older, non-living objects is accomplished by using other radioactive isotopes. So we only carbon date things if they were once living objects. You can't use carbon-14 to, if I dig up a bowl, let's say. I dig up a pottery bowl and I want to know how old that pottery bowl, or an arrowhead or something like that. I cannot use carbon-14 to date those things because they weren't once living. So we would use other radioactive isotopes with longer half-lives, and one of them that we use is uranium, because there's a lot of uranium in the soil. So if I'm making a soil out of a pot out of clay, and that clay came from the soil, then I can use uranium and the half-life of uranium to date, isotopically date that bowl. Okay, so that's basically how we carbon date something, or isotopically date something, and we're going to practice this method in class.